Okay, we are looking at Horsin around. Jen is building a fenced-in yard for her house. We put a box around the word fence because we know that fencing makes us think of what? Area or perimeter? Perimeter. She wants to make a rectangular yard. She has 30 feet of fencing that she can use to make the largest area for her horse to play in after their morning ride. So what is going to be the perimeter of the yard for the horses? What will be the perimeter? Everyone should have their hand up. Everyone should know the answer. Ella? 30 feet. That's going to be the perimeter of the yard. Okay, use the graph paper to draw 2 different rectangular yards Jen could make for her horse using all 30 feet of fencing. So you have to have the perimeter as 30. We don't want 28, we don't want 26, we want the perimeter to be 30. The side of each small square is 1 foot. So this is 1 foot all the way around. Not really, but on this graph paper, 1 square stands for 1 foot. Okay, 1 square foot. Okay, label and measure each side of the rectangles. Mark one rectangle A and the other B. Jen wants to make the largest rectangular dog pen so her horse has the most room to play. So with the perimeter of 30 feet, what can be the length and width to get the largest area? Okay, that's what we're trying to figure out. So come down here below. If the perimeter is 30, what is my formula that we've been using to find perimeter? What's the formula for perimeter?
Area equals length times width.
That is area. That's a good formula for area. What's our formula for perimeter? Perimeter equals 2 times the length plus 2 times the width. And we know that the perimeter is 30 feet. What have we been doing first when we've been finding missing sides? What is the first thing when we know the perimeter, when we've been finding missing sides, what do we do first? When we know the perimeter, what do we do first?
Like split the shape?
Divide it in half. We divide that 30 by 2. Okay, so what is half of 30? 15. So our length plus our width have to add up to 15. What is one possible length and width that we could have for our rectangle? What's one possible length and width for our rectangle? 10 and 5. Okay. What else could we use?
8 and 7.
8 and 7. What else could we use?
11 and 4.
11 and 4. What else could we use, Raider? 14 and 1. What else could I use? Why do I only have 2 hands? I'm just looking for 2 numbers that add up to 15. Caden.
15 and 0.
Well, we can't have a 0. Otherwise, the poor little horse would just have to be walking like on a tightrope like this. That's all he can do. Because there'd be no width. Right? So what else could we use? What about 2? 2 plus what?
2 plus 13.
2 plus what is 15? Okay, I'm asking Caden. 2 plus what is 15, Caden? 13. Okay, give me another one. So we have 1, 2. What about 3? 3 plus, Addie? 12. We've got 4, 5. What about 6? 6 plus, Eli? 9. 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? Those are the only possibilities for our yard. Because our length, it has to be a rectangle, and our length and width have to add up to 15. Now, what does Jen want? She wants her to have the biggest what?
Possible.
Biggest possible what?
Fence.
No. Go back and read the problem. The largest possible what? Area. She wants the largest area. So how do I find the area? How do I find the area? If these are my lengths and widths, what do I need to do to find area? Guys, I need to see more than 3 hands up. Harper Cook. Multiply length times width. So what's the area if my length and width are 10 and 5? What's my area? 50. What if it's 8 and 7? 56. What if it's 11 and 4? 14 and 1? 2 and 13?
28.
3 and 12?
38.
36. And then 6 and 9?
54.
So which one of these rectangles gives your horse the most area to play? Avery. That's not the most. Second most. 8 and 7. And then the second most is 6 and 9. I always think it's kind of funny to think about what if she would have been like, oh, well, let's do a 14 by 1 rectangle. The poor horse would have to be like this running. He'd be all like, he couldn't even turn around. There'd be only 1 foot. Yeah, he'd just do this all day. That's all he could have. So you want it to be the most area possible. So we're going to draw the 2 rectangles. So the first one is 8 by 7. Draw it up here. 1, 2, 3, 4, 5, 6, 7, 8. Ricky, you should be drawing this. 1, 2, 3, 4, 5, 6, 7. And we're going to label it rectangle A. You also need to label the dimensions. This is 8 feet and this is 7 feet. This one's 8 feet and this one's 7 feet. Okay, and then our other one we're going to draw is our 6 by 9. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and that is rectangle B. And again, labeling our dimensions, 6 feet by 9 feet. Okay, so now, which one of these should she choose? Which one should she choose? Rectangle A or rectangle B? Avery? Why would she choose rectangle A? Why don't we actually figure out the area instead of just guessing? Okay, I want you to figure out the area of each one of these. You didn't label the dimensions. Label the dimensions and figure out the area. Ryan? Okay, 56 square feet, 54 square feet. Okay, so how can we explain this? Ricky, you need to write smaller, please. Okay, Jen, if you don't have room to write down here, then write it on another sheet of paper. Jen should choose rectangle A because it has 56 square feet of area for the horse to play. Okay? All right, so tomorrow we're going to do some things in math, and one of them is going to be the other side, which is going to be just like the way we did this side, except with different dimensions. Okay? All right, so let's talk for a minute about RTI. You're going to be working on your slideshow. If you want to pull up your